In this video I'm going to explain how the graph of magnetic flux, measured in Weber against time, relates to the position of the coil in the field. Now remember, magnetic flux is the magnetic field times the area of the coil times the cosine of the angle theta between the plane of the field and the magnetic field vectors. So let's look at 5 different positions: A, B, C and D. So position A is when the field, which is rotating when the coil rotating counterclockwise in this example starts perpendicular to the magnetic field. So there the angle between the normal to the plane and the field is 0. Therefore, since cosine of 0 is 1, we have a maximum in the magnetic flux. So here we are. Then, as it rotates to this position at B, the angle between the plane and the field is 90. So since cosine of 90 is 0, we have 0 magnetic flux. Then, at position C, we've now rotated 180 degrees to the original position, and the magnetic flux is now minimum and negative. Notice the position, due to Lenz's law, the direction rather of the currents has switched due to the fact that in A the magnetic field is decreasing. Therefore the induced magnetic flux acts to oppose the increase, and through the right hand grip rule we get that the current is directed in this sense, and it's switched in C because we have the opposite case happening. Then when we get to D, the angle now is 270 degrees compared to the initial position in A, and again we have that there's no magnetic flux since the angle, or the cosine of the angle, is 0. And then back at E we are back to our initial position, or we've done one whole cycle, which means we're back to the initial maximum magnetic flux.